Okay, our property number 3 is the power property of logarithms. And if you notice, the beginning statement's a little different. It says for any number p, so p could be positive or negative, and you have positive numbers mb, so m has to be positive, b has to be positive, and b cannot equal 1. So we're going to look at this power property. Remember, we have log base um, x of a b is equal to, this is the product, log base x of a plus log base x of b. We also have the quotient, log base x of a divided by b is log base x of a minus log base x of b. And we kind of remember, if we had x squared times x cubed, it equal x to the fifth. Because we're adding the exponents, we're going to add the logarithms. If we had x to the 10th divided by, say, x to the 7th, we would subtract those exponents. So we're going to subtract our logs. So that's a little remember when. Now, if we had x squared raised to the third power, what are we going to do with our exponents? We're going to multiply them. So we'd have x to the 6th. So that's kind of what's going on here. We have log base b m raised to the p power. Well, this product, or this power property, basically says we're going to take this exponent and we're going to move it to the front of the log. And so we have p times l log base b of m. So let's take a look at this one. We have log base 3 of 25. Well, 25 is actually equal to 5 squared. So log base 3 of 5 squared. And we could take our 2, stick it to the front. So that's really equal to 2 times log base 3 of 5. And to show that that is equal, go to our handy dandy calculator here and hit the math key, and log base 3 of 25 is equal to 2.9299, approximately equal to 2.929947, blah, blah, blah. And so we could take and show 2 times the log base 3 of 5, and we're going to get the exact same thing, 2.99, just like we did there. So you can see that those are equivalent. So let's take a look at this guy. We are going to expand him. That's our goal, is to stretch it out. So we have a 2, so we're going to pull the 2 to the front. So 2 times log base 4 of 3x. Now, can we expand that a little further? We can, because this part is equal to log base 4 of 3 plus log base 4 of x. Now, we need parentheses because we are doubling what this is equal to. Well, this whole thing is equal to this is equal to this. So we need to have parentheses there. We have to have parentheses. So that's how you would expand it. Now, that compared to this guy. This guy right here, the square only applies to the x. It doesn't apply to 3, unlike this one. So the first thing we have to do is we have to separate the 3 and the x squared. So we'd have log base 4 of 3 plus log base 4 of x squared. That squared does not apply to the 3 in this case. So now we can move it, but we're not going to move it over here because then that would apply it to the 3. We're just going to move it to here. So we'd have log base 4 of 3 plus 2 log base 4 of x. Moving on to example 3, we have this guy. We need to shrink him. We need to pull him back together because we want to figure out what x is and show that those two sides are equal. So we have to go in reverse. So we need to move those exponents back where they go. So we're going to move him. We're going to move the 1/2. And so really this says log base 10 of 8 cubed minus log base 10 of 36 to the 1/2. Now, subtraction means what? Subtraction means it's our division, our quotient property. So the first one is going to be the numerator. So we have log base 10 of 8 cubed divided by log base 10, or divided 8 cubed divided by 36 to the 1/2. And that equals log base 10 of x. Well, I have the same, this guy shifted him up too far, but my log should have been bigger there. But anyway, so I have log base 10 equals log base 10. So we know these two pieces have to be equivalent. And so you can figure out what those are. Well, 36 to the 1/2 power is the same thing as the square root of 36, so that would be 6. And then we have 8 times 8 times 8. And so we would have 8 cubed. And then divided by 6 gives us, so x is approximately equal to 85.333, or 85 1/3. And that would be how you would solve using the power property. Actually, we used the power property and we used the quotient property. So all of those are going to kind of come together.